Hi, my name is Dan, and I'm a graduate student at the University of Wisconsin-Madison, working in the Multiscale Metals Manufacturing Processes Lab. My specific research is on the process of friction stir welding, so that's what we're going to learn about today. Friction stir welding is a joining process for metals. So whenever you're trying to build something or manufacture something, typically you're going to have a bunch of smaller parts that you have to combine and join together to get your final product. For example, if you think about a car is going to have many various different parts. Some of those parts are going to end up being welded together because welding is a very good method of joining metals. If you think about joining, most of you have probably done some joining. If you've ever glued something together, you've done joining. You could use glue to glue metal together, but glue is typically going to be weaker than metal, so we tend to use a process such as welding that create joints between pieces of metal that are of the same strength as the metal itself. The way that friction stir welding works is you have a tool. This tool is going to rotate, plunge into the material, and it's going to slowly deform the two pieces of metal together to create a continuous solid piece of metal. When thinking about deforming a metal, the easiest way to think of this is the example of bending a paper clip. In friction stir welding, we're essentially doing the same thing, but we're deforming the metal around the tool in a rotational manner. Metals tend to deform easier at hotter temperatures. What's interesting about friction stir welding is when you deform metal, the energy that goes into deforming the metal actually generates heat, which heats up the metal and makes the metal then easier to deform. A good example of this is if you were to take that same paper clip and then bend it back and forth as fast as you can many times, and then touch the area where you bent it, you might notice that it is heated up slightly. Even though heat is generated, we still do not completely melt the metal. This makes it a solid state joining process, which is different than a fusion welding process where you would melt two pieces of metal and have them fuse together when they resolidify. So let's go ahead and jump to the demo. So here we have two pieces of aluminum. You can see the seam down the center. Above it we have a tool steel tool. So what's going to happen here is the tool is going to start rotating. It's going to fully plunge into the material until that smaller diameter probe is fully submerged in the material, and the larger diameter shoulder is residing at the top surface of the plate. And then the tool is going to traverse along this seam between our two plates, and it's going to intermix these two plates together by stirring the metal around the tool, kind of like you would stir cake batter. So during this process, we're generating temperatures on the order of 80 to 90% of the melting point of the metal. So close to melting, but not quite melting. Once it reaches the end of the weld, the two plates are fully fused together. And if you were to touch the plate, you would see that it is slightly hot. Next, we're going to go over some applications of where friction stir welding is being used in industry today. It's used quite a bit in the transportation industry, such as trains or marine ships. It's also used now currently in rocket ships by SpaceX, such as the Falcon 9 rocket booster. It's well suited for these applications because it's well suited for long, straight joining processes, so they can use this to make stiffened panels that then become part of the ship or the rocket ship. It is also used to make aluminum car door panels, which have helped make automobiles lighter. Additionally, it's been used in the aluminum casing around the monitor of the iMac, which also helped make the iMac 40% thinner. Friction stir welding is often compared to your standard method of welding, which is known as fusion welding or arc welding. In arc welding, you use a very high current of electricity to generate a lot of heat and melt the two pieces of metal. What's interesting about friction stir welding is it actually takes less energy to deform the two pieces of metal together than it does to fully melt the two pieces of metal. This makes friction stir welding a more energy efficient process compared to arc welding. This is important because as we move forward with trying to develop new methods of manufacturing, we want to have consideration for the carbon emissions related to our process. Additionally, because it produces lower heat, we tend to get a stronger joint with less distortion. And we don't need the expensive shielding gas that's often needed in arc welding to protect the molten metal from the atmosphere. Lastly, friction stir welding has been known to be able to join very different materials, which can't be done with arc welding. Now I'm going to pass off the presentation to my colleague Mo to talk about some limitations of the process, as well as research we're doing here at UW.
Hello everyone, my name is Mo Ansari and I'm a third year PhD student at M3PL Lab at University of Wisconsin-Madison, Department of Mechanical Engineering. My area of expertise is friction stir welding and simulating the manufacturing processes. Let's talk about limitation of friction stir welding in this slide. Friction stir welding has advantages which was discussed in previous slides, but the limitation of friction stir welding is listed at below. We have high process force which cause an expensive machines and logistic for the process. We have limitation on design changes for friction stir welding and geometry of the process, and the tool wear is a common phenomenon in friction stir welding of steel. The research at UW-Madison on friction stir welding is listed at below. We're working on understanding void formation based on the static and dynamic X-ray imaging during the process. Also, our group is working on the sensing the sinusoidal force signal when voids form. Having this knowledge helps us to reduce the weld's inspection for voids. And last but not least, we're working on the simulating void formation through FEA analysis. This slide shows the simulation results of void formation during the friction stir welding. White area at the center is void, which is predicted by the numerical analysis in this study. And thank you so much for joining us.